Hi everyone, I'm Yuqian Tang. Today I'm going to introduce our work, RSVP, Customer Intent Detection via Agent Response Contrastive and Generative Pre-training. Intent detection is a critical capability for customer service agents in task-oriented dialogue systems. The agents have to identify the correct intent of each customer utterance in order to dispatch it to the corresponding following progress. However, it could be quite time-consuming for agents to annotate it. That's why we need a model for an automated intent detection. Why this is a critical problem, it could accelerate customer service, as the late response might lower customer satisfaction, and the agents can focus on other crucial services. Previous state-of-the-art methods rely heavily on large amounts of annotated training data for pre-training language models, but high-quality intent annotation at scale is expensive and time-consuming to collect, especially for relatively minority languages. Besides, they mainly focus on directly learning from the customer utterances, while neglecting that incorporating the other in-house metadata can benefit the training. Our key intuition in our proposed framework, RSVP, is to learn from agent responses during pre-training in parallel with the customer utterances. The idea is that if the model is able to provide an accurate response for a given utterance, it must have inferred the hidden intent behind the utterance. In real-world customer service logs, agents respond based on their understanding of the customer's intent. So modeling to generate accurate responses teaches the model useful intent signals. Concretely, we introduce two pre-training tasks as a pre-training stage, and then fine-tune our model on the intent detection task. I'm going to elaborate them step by step. First is response retrieval, which trains a conversational encoder model initialized with BERT to select the correct response from a set of candidates for a given customer utterance. This teaches the model better utterance representations. Second is response generation. It trains the conversational encoder and the response generator model initialized with BERT to come up with an appropriate response to an utterance. This aligns the model closely with how real agents think and respond. After pre-training on agent responses, we fine-tune the conversational encoder model on the downstream intent detection dataset using standard classification techniques. Additionally, we use an unsupervised contrastive loss to improve model robustness. This forces consistency between augmented versions of the same utterance. This is the whole architecture of RSVP. We extensively evaluate RSVP on 4 customer service datasets. RSVP substantially outperformed strong intent detection baselines like CPFT and CompBERT, improving intent accuracy in a statistically significant manner. Ablation studies also validated that both pre-training tasks, pre-training task order, and the contrastive loss were crucial to the performance gains. Besides, we also experimented with the encoder-decoder model architecture, replacing the BERT encoder with MT5 encoder, and the results also indicated that MT5 is not as effective as BERT across all datasets. For case studies, we present a few randomly sampled utterances and their corresponding generated responses by the trained response generator with their predicted intents. Although the quality of generated response is not the primary focus of this work, it can be seen that the generated response can effectively answer the utterance, which may open another direction to adopt this for automatic replies in the future. To further illustrate the effectiveness of RSVP, We visualize the utterances representations from test set with different training stages of the conversational encoder. It can be seen that all the trained encoder learn better utterance representations and intent boundaries than the vanilla one, and RSVP with the whole training progress can show the clearest intent boundaries. In summary, RSVP provides an effective framework to exploit agent responses for intent detection pre-training without needing to collect any extra annotated public data. It also takes advantage of contrastive learning and gains robustness over the other baselines. It could generalize well to other task-oriented dialogue systems beyond customer service, and we look forward to the broad application of the framework.